There's a story that Galileo had an assistant simultaneously drop two spheres of differing mass from the Leaning Tower of Pisa to demonstrate, contrary to Aristotle's predictions, that objects freely fall at a rate independent of their mass. Aristotle had written that objects twice as heavy should fall twice as fast. The result of Galileo's demonstration showed that the spheres landed at nearly the same time, but the smaller sphere was a tiny bit late. Why? And so the thing to recognize here is like Galileo is trying to support the idea that all objects in free fall are falling at the same rate, regardless of how big or small, in other words, how much total mass or how much total matter is in them. And clearly, if the two spheres don't land at the same time, that doesn't agree with that. But if you can compare that, though, to the prediction that Aristotle made that objects twice as heavy should fall twice as fast, the fact that the tiny sphere is only a tiny bit late is actually quite a bit more different than what Aristotle had said. And the question here again is why? And this was something that Galileo actually understood. He recognized that air drag was an issue. And we know today that if you were to repeat this experiment in a perfect vacuum, and this has been done, I think I've seen a dramatic demonstration of where like a feather is dropped in a vacuum and it falls just as fast as any other object in a vacuum. It's really quite amazing. You might be able to Google that and find some video like that out there. It's really kind of amazing to watch. But again, air drag is the issue. For something that is smaller and has less mass, the relative effect of the air drag is going to be a bit larger, and therefore it will fall just a tiny bit slower. But what Galileo recognizes, that's not really the fundamental way that things work in nature. And he didn't really fully understand gravity yet. It had to wait till Isaac Newton to really get that all figured out. But he did recognize that the existence of air drag was making it more difficult for us to make those kinds of discoveries. And he had to think about that in all of his experiments, including this one. So there it is, air drag. And again, had it been done in a perfect vacuum, that formula D equals 1/2 gt squared, that would hold exactly, provided it's done here on Earth where g is equal to 9.81 meters per second squared.